All right. Good evening. My name is Niccole Thomas, course 6356, Quantitative Research under Dr. Cioci. I'm back for VRJ 3, conducting a single sample t-test, parametric test, and non-parametric if I have normality is violated. So I'll begin by sharing my screen. And I'm going to start off with, let me make sure that, okay. Some of my presentation results. I tried to do screenshots. I did add in some screenshots to this, but I wanted to go ahead and go over this part before we begin our analysis and running tests, all right? So the first thing that I needed to do was to verify alignment, and that's through my research questions. All right, so my research question is there a significant difference between the mean reading score of sixth grade students and the state benchmark of 92 at Texas K-12 Success Initiative? My primary verb here is in the research question, it is comparative. Significant difference between, right? It signifies a comparative design. And so the sample mean is being compared to a known population value as my independent variable, and that is the state benchmark of 92. So being that the verb is comparative, I'm comparing one group, only one group, and it's compared to one known value that signals a single sample t-test, and that is the appropriate test. I'm also using reading scores as the dependent variable. It is continuous, it is on a ratio level, and it meets the requirement for the test. All right, so let's take a look at the data. These are the screenshots from me running the analysis. Let's go through that first. I'll keep making sure that you are able to see. I'm going to unshare. I'm going to come off. Stop share. Not unshare. I'm going to stop share to make sure that you're able to see. Okay. Making sure. All right. So let's do the, we're going to do hypothesis testing. All right. Our null hypothesis here is that there is no significant that there is no significant difference between the mean reading score of sixth grade students in the K-12 Texas Success Initiative and the benchmark, the state benchmark of 92. So the null saying that nothing special is happening here. H naught or H sub O or H sub 0 is mu equals 92, okay? There's nothing changing, nothing happening on either end, higher or lower. That's what the null says, all right? So if we reject the null, we have the alternative, which is H sub A, and the mu does not equal to 92, then and it implies or indicates that something special is taking place. There is a significant difference between the mean reading score of sixth grade students in K-12 Success Initiative and the state benchmark of 92, all right? So with that being said, this implies that this will be a two-tailed test. And so now we're ready to take a look at our, we're ready to analyze. So let's go to SPSS, where I have already been manipulating the data. Let's take a look. All right. So here, okay, it's showing. Let me stop sharing. Come back out. All right. One other key or important information that we want to make sure that you that I do say is that I needed to check my assumptions and I needed to verify that my dependent variable is continuous, and it is because I'm using reading scores. Okay. Look, random sampling, it does not meet this qualification because it is a sample of a larger population. We're generalizing to sixth grade specifically, and then independence. And this assumption is met because all of the scores are independent of every other student score. Okay. And so now we can begin to run the analysis. Make sure that you're able to see my screen. All right. As I said that for the sake of time, I did go through and begin the process. I want you to see the data editor window. We have our variables from when we worked previously in modules 1 and 2, with the variables being coded. So we took a look in our data view. I went through data view, and because I'm looking at sixth grade specifically, I needed to go ahead and select the cases for sixth grade only. And so I did this by selecting the cases. And if condition is satisfied, it looks like my screen is stuck. So let me go back and stop share and make sure that you can see what I see. Share my screen. All right, I think. Okay, so as we see, we can see the diagonal lines here, and that's because I've already been manipulating the data. I did show the variable view from when we were looking at this data during modules 1 and 2. We're going back to the data view, just showing what I did. I did use the tab for data, select cases, and if the condition is satisfied, I want to look specifically at grade level. Move it over here, and grade level equals 6, and I want to take the spaces out. So I don't want any issues. All right, I'm taking the spaces out. I want to hit continue. Okay. See what the statistics said. I have been working on this, and so it is pulling up from where I've been working with the same data output, I should say. And so if we look at trying to find our statistics. I want test statistics when we get this information. Check to make sure that you can see. All right, this is the information. I know that it is cluttered, and that's because I've been doing a lot with it. I've been practicing with it. So when we look at the one sample statistics, we get the reading score of I'm sorry, the number of 628. And what I didn't show you was here, the number was 863. I did select my cases. I don't know if it'll filter out and show you that part again. Let's look at it now. There it is. It was 868 selected cases. My filter is on, and it filtered out every other case with the exception of sixth grade. All the data is there for sixth grade. That's what's being shown. All right. And so at this point, now we're going to navigate to analyze. We want to compare our means. I want to complete a one sample t-test. And now I want to look at the reading score as my test variable. I want to make sure that I change the test value to 92 because that's the benchmark, state benchmark value that we're working with. Okay. And as you can see, we're here with a lot because I've been working on the same document output. I should say I've been working on this, and this is what it's showing, all of the charts and the histograms. Okay, so now of the 864, I believe, cases on the one sample statistics, we have the number of 628, right? And we have a mean. We see the mean is 90.83, and it's a little bit less than our actual target of 92. We have a standard deviation of about 8.6. And so here is our sample test, one sample test. There's our test value of 92, our t-value. It's a negative 3.427, the degrees of freedom, which is our variability right here. And there's our tail, our two-sided p-value. But here is our the part that is important for us, our 95% confidence interval right here. Lower, negative 1.84, upper, negative 0.5. So it did not include 0. So this is a trustworthy test sample right here. And we look at Cohen's D, we get a point estimate of about negative 0.137. And I did the calculations. Back to making sure that you can see my screen. All right, let me go back to the window. This is what I wanted you to see, which is the same. This was a screenshot of the material or the data. This is the same screenshot. And here, this is where we worked on, interpreting what everything meant. So one sample t-test was conducted to determine whether the mean reading score for sixth grade students in Texas K-12 success initiative differed from the state benchmark of 92. And 90.8 was our mean. Our standard deviation, the numbers still show 8.6. This is our number. It was significantly lower than the benchmark. And therefore, the null hypothesis was rejected. So we set the p-value, the alpha at 0.05. And so the p-value was less than the alpha. And so we had to reject the null hypothesis. And so this indicates that there a statistically significant difference between the sample mean and the benchmark. Let me check to make sure my screen is showing. Okay, let's go back to SPSS. All right, now I want to check normality to see if it was violated and make sure that you were there. All right, back to our variable view. So I'm gonna check normality using the Shapiro-Wilk test. We're gonna use histograms and the Q dash Q plot. So let's start off with show up and analyze. Let's go to descriptives. Explore. All right, I already have reading score there. We'll use plots on the histogram. Normality plots test. All right, continue. Okay, plots. This is there too. All right, and let's see, test of normality, degree of freedom, that's the variability, and there we are. It is, P is less than 0.001. There's the significance. Let me scroll down. And we have a few outliers over here, very small. When we look at the shape, let's see if, all right, so with our Q-Q plot of reading score, we have some outliers at the bottom of the diagonal line, and just a little bit, just one actually. Well, we have some falling off the line right here, and maybe one over the top here. So we have some skewness. So let's go up and let's do the actual Shapiro whistle. Analyze descriptive statistics, and explore. Still gonna do the same things. Okay. So it looks like I did things correctly. And we're looking for if the p-value is greater than 0.05, then some normality is detected, or it is reasonable, I should say. If it is less than 0.05, then there's a significant departure from normality, and we actually saw that on the here. It kind of skewing away from the line, the bottom. The median seems to be intact. And there it is. It's less than, so it never goes all the way to 0, but it is. It's less than. All right. And now we need to make a decision. We want to compare p-value to the alpha level. And we set the alpha at 0.05 at the beginning of the test. So it was already set there. And so since the p-value is less than if the p-value is less than 0.05, then we reject the null. So if I go back to my PowerPoint, let me stop share to make sure you're able to see what I see. All right, just making sure that you're able to see. All right, so we're going back to our data, okay? And this shows that when we go back, that since we're rejecting the null, this shows that my alternative hypothesis was correct. There is a significant difference. There is something special or significant happening there. When we need to look at the sample effect sizes. So we're going to calculate the coins D, all right? And we're going to use the standard deviation to help with this. So we look at the mean difference. It's a negative 1.167, and we got this because the mean was less than our target of 92, all right? So we ended up with negative 1.162 or negative 1.2, and we divided that by the standard deviation of 8.6, and we see the coin D was calculated to be negative 0.137 or negative 0.14, and that is when we look at the confidence interval, and we do not use zero, or we do not come close to zero, then it is a trustworthy score, right? So we want to report, this tells me also, when we look at negative 0.13, that's a very small sample size, all right? Very small. So now we want to go up and interpret the data. All right, so using APA standards, a one sample t-test was conducted to determine whether the mean reading score of sixth grade students in Texas K-12 Student Success Initiative differed from the state benchmark of 92. Let's make sure that you're on the screen. And so these are our results. And it indicated once before that the null hypothesis was rejected, indicating a statistically significant difference between the sample mean and the benchmark. I'll stop sharing, go to the next section. Yes, hold 1 second, let me fix this. All right, so I'm just trying to make sure that you're able to see my screen. All right, so one of, I guess I should also mention that the test with the mean being 90.8, and students, the data shows, or we interpret the data, I should say, that it shows that the the gap was real, and there is a need for reading support, because we rejected the no, that nothing specific, not specific, but nothing special was happening with the data. But in running the analysis or the t-test, we found that we were able to reject the no. However, normality was violated. And because of that, I had to run the Wilcoxon test as well. And so I want you to take a look at that data, because with the Wilcoxon test, we noticed that the there was skewness in the data. Let me share. Stop there and make sure that you can see. And share. Go back to sharing. Let's go back to this. All right. And so when we look at, we can find it. Okay, so when we look at this box plot, let's make sure that you can see it. All right. You see the data is clustered all the way down past the bottom of the plot. And also we have a lot of outliers as far as the data. We have the histogram is left-tailed. And so because of it, we noticed that this non-parametric test, it is not agreeing with the parametric test. It is not agreeing with the t-test. And so looking at the literature and doing some troubleshooting, I found that it could be, one of the causes could be the large sample size that I have, with it being 628 sixth graders, could cause the data to be skewed and not align or agree with the t-test. And I'm going to go back to our actual data. All right, so suggestions for future research. And I felt like this could be a great suggestion for future research, because the data was skewed and there were potential outliers, and it caused the number to be, it caused it to be skewed and not in agreement with the parametric test. Future research could more closely examine how skewed score distributions and potential outliers may be shaping interpretations of reading achievement. The histogram showed or suggested that scores were clustered near the upper end of the scale, close to 100, and it had a left tail pattern. Also, with the box plot, they were clustered down under the bottom of the plot. So it raises the possibility that a small number of unusually low scores are populating and disproportionate, having a disproportionate influence on the mean. So it's sort of pulling the mean down. So that could be a suggestion for future research. Also, including additional grade levels and subject areas could help educational leaders better interpret the assessment data and design targeted interventions to improve student outcomes. I hope that I was able to explain running the t-test, and also uh, finding where normality was violated, running the Wilcoxon test. I hope I was able to explain that correctly. This is the end of my segment. Thank you. Good night. Share.